Hey guys, so in today's video we will be going over test 6.3 review. As you can see, I'm going to be doing the right side, so the evens, and then for your assignment you'll be doing the left side, the odds. Remember that the reviews have been taken for a grade this 6 weeks, so make sure that you get this review in on Canvas. We'll go ahead and get started. In this first section is just to solve each equation, and remember we got to check if our solutions are extraneous. So on this first section, 1 through 4, we're solving irrational equations, which means we're dealing with fractions. On number 2, we see that we've got two different denominators, and so whenever that happens, we want to factor the ones that we can, and then see what we need to make them all a common denominator. So this first one, I can take out a v, which will leave me with a v minus 3. And then we see that they all have v minus 3 now, but they all still need a v. So we're going to multiply by v on top and on bottom for the ones that are missing a v. So that gives me 1 over v times v minus 3 plus 1 times v is v over v times v minus 3 equals 2 times v is 2v over v times v minus 3. So now that they all have a common denominator, we can just work with the numerators and then solve that equation. So we've got 1 plus v equals 2v. So you can see where that came from. And then we're going to solve that for v. And we get 1 equals v. Now, when we're trying to decide whether this is extraneous or not, we want to plug in a 1 into our denominators and see if we get 0. So if I said 1 minus 3, it's not 0. If I said 1 squared minus 3 times 1, it's not 0. So our answer, we can write it as a set. We can write it as just v equals 1. But our answer is 1. Then on number 4, we have the same type of problem. We've got a rational equation, and we have two different denominators and then a whole number. So in order for them to look the same, I need this one to multiply by a 3 on top and on bottom, and this one needs to multiply by a 3n because it's missing both of those. So we get 1 over 3n equals 3n over 3n, which is the same thing as 1, minus 2 times 3 is 6 over 3n. Now we have a common denominator all the way across, so we'll say 1 equals 3n minus 6. We'll add 6. We get 7 equals 3n, and we'll divide by 3, and we get that n equals 7 over 3. Whenever I plug 7 over 3 in to either denominator, n would equal 7 over 3, and then 3 times 7 over 3 is 7. Neither of those are 0, so we don't have an extraneous solution. N would equal 7 over 3. Now in this next section, it says to state the excluded values. Excluded values are what makes the denominator equal 0. If these were functions, this is on the test, so make sure you're paying attention to this part. For functions, this is restrictions on the domain. So that could be from wholes or from vertical asymptotes. So whenever it says state the excluded values, these are excluded from our domain. So it's whatever makes our denominator equal 0. So n plus 3 equals 0. subtract 3. -3 would make our denominator equal 0, so it is excluded. So we'll say n cannot equal -3. Same thing with number 8, but now we need to factor. So number 8 and number 5 are going to be solved the same way. So between 35 and 30, a common number is 5. And between x squared and x, I can take out an x. This leaves me with 7x plus 6. And we want to set our denominator equal to 0. Remember, whenever we have two parts equal to 0, when they multiply, we take each one separately. So 5x equals 0 means x equals 0. 7x plus 6 equal to 0. And we get x is equal to -6/7. So excluded from our denominator, excluded from our domain, a restriction on the function's domain would be 0 and -6/7. Now on the next section, we're finding the inverse of each of our functions. These are our log functions and exponential functions. So on number 10, first thing we do on all of them is going to be switch our x and our y variables. And then we solve for y. So x over 3 equals log base 4 of y. And then we can convert. We get 4 to the power of x over 3 is equal to y. Y is by itself, so we can stop there. Number 12, switch our x and our y variables. Convert, since we don't have anything that we can move around first. We get 1/3 to the power of x is equal to -4y. Divide by -4. And we get 1 over, -4 times 3 to the power of x. I took the power of x off of the 1 because 1 to any power, it doesn't matter, is going to be 1. 0 makes anything 1. 1 to the first power is 1. 1 squared is 1. 1 cubed is 1, etc. So I just took it off of there. The 4 doesn't have the power of x, but the 3 does. And that is equal to y. Number 14, x equals 5 to the power of y minus 5. I want to isolate the exponential as much as we can. We get x plus 5 is equal to 5 to the y. We can convert. Base stays the base. Others switch sides. And we've got y by itself, so that is my inverse function. On number 16, we've got x equals e to the power of y over 4 once we switch those variables around. And we're going to convert. We get log base e of x is equal to y over 4. Log base e has another name. It's the natural log. So we have natural log of x is equal to y over 4. Multiply by 4 on both sides. 4 natural log of x is equal to y. Next section, we're condensing into a single logarithm. So on number 18, we want this to just be one single log. I'm going to rewrite that with the fraction as a coefficient. So instead of dividing by 3, I'm multiplying by 1/3. It's the same thing. I just rewrote it. And then my coefficients become powers. This is log base 4 of w to the 6th power plus log base 4 of u to the 1/3 power. Then we have plus in between two logs with the same base, which means we're going to multiply. So log base 4 of w to the 6 times u to the 1/3. That's one single log, so we're done. Number 20, we're going to take those coefficients and make them powers. Then I have two that have the same base. We've got log base 6 on both with a plus in between, so that means we're going to multiply. On the next section, 22 and 24, we are expanding the logarithm, so we want to make it into more than one log. So whenever they are multiplying, that means there is addition in between them with the same base. So log base 3 of u to the 4th plus log base 3 of v squared, and then our exponents become our coefficients. So 4 log base 3 of u plus 2 log base 3 of v. And that's as much as we can separate, so we're done expanding. On 24, we're going to take that power down. So we've got 2 log base 9 of x to the 5th over y. Whenever there is division, we separate them by subtraction. And remember, both parts have this square in them. So this is 2 log base 9 of y. And now this power needs to come to the front. So we have 2 times 5, which is 10 log base 9 of x minus 2 log base 9 of y. The next section we're rewriting in exponential form. This is what we're going to use first. Last and middle. This is just a refresher in case you have to do this on the test. This is not necessarily what we are testing you on, but it is going to be part of some of the problems. So you do have to know how to do it, so that's why it's been included in the review. So this is the first, last, and middle. So this is y to the power of 20 is equal to x. And that's our exponential form. First, last, middle. 11 to the power of negative 2 is equal to 1 over 121. Oops. Then on the next section, we're writing it in logarithmic form. Again, we're going to be using first, last, middle. So it just means our base stays our base and the other two will switch sides. So we've got log base 14 of 198 is equal to m. And log base n of 147 is equal to negative 19. So then those are all of the evens for the test review. You are responsible for all of the odds. And then remember, this will be taken for a grade, so make sure that you get it completed and then turned into Canvas on time. And then good luck on your test tomorrow.